happy to be here and being joined by my co-host Michael. My name is Marie. You've probably seen me here before. I've been with AWS for a while, and I am in the partner solutions architect world. So Michael, how are you doing today?
I'm doing great. Having a beautiful day outside. The sun is shining. I can't wait to get out there myself. But for those of you that haven't seen me on the show before, my name is Michael Leando. I'm a senior developer advocate on the Amplified team here at AWS. And I'm really excited to have our guest on today. We have Prasanna. Prasanna, how's it going? And what can you tell us about our story today?
I'm doing good. Hope you guys are doing great as well. My name is Prasanna. I am a senior solution architect here at AWS. I work in the educational technology space. My experience and background comes from data engineering, big data analytics, and data warehousing, etc. I'm excited to be here to talk about orchestration and choreography, what they are, what are the pros and cons, and hopefully it will give you some kind of guidance on what approach you are to choose.
Awesome. Yeah, I'm really looking forward to learning. I have a lot to learn in this space. So, yeah, I guess why don't you start off and tell us a little bit about the problem, why we should even be looking at orchestration versus choreography?
So let's take a small application, for example, right? So you have like a couple of features that you built into the application, and everything is fine and dandy. And suddenly your business grows, and you want to add more and more features to the application now. And all of a sudden, after like maybe a few months or years or whatever it is, then the application becomes so huge, and this is what we call a monolithic application. And when you're stuck with a monolithic application, it becomes very difficult to manage. So it becomes like a maintenance overhead, right? So what we typically try to do is we try to split the monolithic application into smaller chunks. So when you look at the application, it's like it has maybe like 10 features built into it, right? So each of those features can be seen as a small microservice. And when you split those microservices, you tend to think about how do these microservices communicate with each other? How do they interact with each other, right? So this is where orchestration and choreography comes into picture. So these are basically two different approaches through which the microservices communicate and interact with each other.
It's awesome. Okay, I get it. So when you start off with a monolithic application, we've all kind of heard some of the pain points that those can create in terms of maintainability. So along come orchestration and choreography. Can you give us just a little sneak peek into what each of those mean?
Sure. So when you take orchestration, right, the first thing that comes to your mind is an orchestra. Orchestra is like a group of musicians who are performing beautiful music for us. And in the middle of all of these musicians, right, so we have like a central conductor who is conducting the whole orchestra. So there's always some kind of communication that goes on between the central conductor and the musicians. And the conductor is responsible for for all these musicians to perform at a particular point in time, right? So when we take the same analogy and apply it into the design principles, we have an application where you have a central coordinating process, and that coordinating process is in constant communication with the microservices, which are all the smaller services that is the surrounding around the coordinating process. So if you look at it, it's more like a request response kind of approach, where the request is sent from the coordinator to the microservice, and the microservice responds back with a response, right? So this is what orchestration looks like. So let's take a real world example. So let's say you go to Amazon.com and try to order something, and you browse to the website, and then you try to see what the item you want, and then you add to the cart, and then you submit it. And let's assume that the backend system is built using the orchestration approach. So now your order has been submitted. So now the central coordinating process gets that order, and it will start communicating with, for example, maybe an inventory system or an inventory service. It's going to say that, hey, we have an order from the end user, so give me whether this particular item is in stock or not. And the inventory system looks up and then sees whether the item is in stock or not, and then sends a response back. And now that the coordinator has that particular answer, it can now go ahead and communicate with, for example, an invoice system. And you can say, hey, we have the item in stock that the end user requested or ordered, and can you give me an invoice for the same? And the invoice system goes and does its thing. It gives an invoice back, and that is the response that is sent back to you as the end user. So this is how an orchestration looks like. So there's a central coordinating process that communicates with all the other services surrounding it, right? So this is orchestration.
Yeah, I love that example. So, yeah, so thinking about that, Obviously really helps to put it in real world terms. So just one person coordinating a group or a coordinator coordinating things to deliver something. So I'll definitely think about that on my next Amazon order. But yeah, so I love to hear about orchestration and how that works in this context. What about choreography?
So there is a very small, subtle difference between orchestration and choreography, but an important one. So choreography is another approach where the microservices interact with each other amongst themselves. So let's take like choreography. What immediately comes to your mind? A choreograph. What do you choreograph? A dance group, right? So let's take there are like a group of dancers who are dancing, and if you carefully observe, there is no central coordinator who is conducting the dance. The dancers are all in constant communication with each other, and they all try to look for subtle signals or some kind of trigger from other dancers so that they can go ahead and perform their piece. They all like move as a team, as a cohesive unit. So that analogy, when you apply it into the IT principles, you have this application where there are a bunch of microservices, and all these microservices are in constant contact or in constant communication with each other, right? So this is otherwise called as like an event-driven approach. So let's take the same example. So you go to Amazon.com, you try to order something, and you submit an order. So let's assume that the backend system is now architected using the event-driven approach. Okay, so now and when you order something and the order is created, that acts as an event or a trigger. And all these microservices, they are waiting for the trigger so that they can go ahead and perform what they're meant to do. So let's take the inventory system. Will identify this particular event, and then it's going to go and check whether the particular item is in stock or not. And if it is in stock, it's going to go ahead and communicate itself to the invoice system. And the invoice system is going to produce the invoice, and then that invoice is sent back to the user as a successful order is submitted. And in addition to that, the invoice system can also go ahead and say, hey, there's a reporting system out there. I'm going to send this particular event to the reporting system. And the reporting system will acknowledge that event, say, hey, this particular event has to be added to our sales report. So it can go ahead and do that. So if you see here, there is no central coordinator who is coordinating all this, but the microservices are all communicating with each other and getting the job done. So this is what choreography looks like in real time.
Awesome, got it. So first off, I love the fact that for many of these talks that we have, we can simply give a solution that Amazon sort of has within its own within our own company, because we often dog food our own services. Uh, now, so in my mind, mentally, you give us this picture of an orchestration where there's this conductor. So I see that as like a central hub. And then in an event driven application, you have a sort of step by step workflow where the smaller functions are, or services rather, are talking to one another. Some services are coming to mind, but can you give us a breakdown of what AWS services typically work best in either use case?
Sure. So when you take orchestration, we have a couple of services here. The first one is AWS Step Function, and the second one is AWS Amazon MWA, which is Managed Workflow for Apache Airflow. AWS Step Function is more of like a serverless, low-code visual interface service. So when you go into the Step Function tool, what you will see is it has integrations with a lot of Amazon services. So you can just drag and drop the service into the visual interface, and with very minimal code, you can actually create like an entire workflow that you can run directly from that window. And when you start running or executing that particular workflow, you will see in real time what particular step is currently running, what are the steps that are waiting, if a particular step has failed, and you can even see the communication that's happening between multiple steps, where what data is coming out of one particular service and what data is going out into the other service. So this is AWS Step Function. It's a very cool tool, and I would really encourage you to check it out if you have not. The other service is MWAA, Managed Workflow for Apache Airflow. Apache Airflow is like an open source orchestration tool that came out of Airbnb, and it became like a top level Apache Foundation project a few years back. And MWAA managed workflow for Apache Airflow is more of a fully managed solution from Amazon for Apache Airflow. So it is a fully managed service. It is very, very easy to set up. It works on a backbone called DAG, DAG, Directed Acyclic Graphs. You write these DAGs using Python language, and then you create all of these end-to-end data pipelines, and you can actually execute these pipelines at scale. You can schedule it. It's a full-fledged orchestration tool where you can actually run these end-to-end data pipelines at scale. So these are the two services that aid for orchestration pattern, right? If you look at choreography, the back end of the choreography is events. So because we call them event-driven architecture for a reason, because they are relying on the events, and events are handled by what is called an event router. And we have a couple of services that actually act as event routers from Amazon. One is Amazon Event Bridge. The other one is Amazon SNS, Simple Notification Service. If you take EventBridge, it is an event bus. It's a fully managed event bus, a serverless event bus, and it is built with event-driven architecture in mind. It can act as a backbone for developing a full-fledged event-driven application. It has some features and some features that are really important. So, for example, it has a lot of third-party SaaS integration, so software as a service integration. So, when you want to ingest or when you want to consume events from other services, other SaaS applications, you don't need to write your own code, because EventBridge can actually have the native integration with a particular third-party software. And there are also another feature is like routing rules. So let's say you have like a publishing system which is publishing these events into the EventBridge, right? And then you have all of these consumers here. So let's say you have like 4 different consumers who are trying to consume those events. What typically happens is they consume all the events, and each of these 4 systems can have some specific functions, and they can only care about some specific events. So, for example, right, the invoice application only needs to care about the orders getting created and nothing else. So, the routing rules gives us the ability to actually filter those events and only send a subset of those events to a particular destination. So in this case, the consumers don't have to actually consume all the events that are coming in from the publisher. They only worry about the subset that they really care about. So this is one of the cool features of EventBridge. The other feature I can talk about is a schema registry. So let's say a consumer is trying to consume an event, right? It needs to understand what structure that event is, right? So it needs to understand like what is the layout of that particular event. So EventBridge has this schema registry which can actually automatically infer the schema and then store it in the schema registry, which can be used by the consumers to actually read that event and understand the event and process the event in the app.
Question on that. Can you download the schema into VS Code, or how do you do that there?
So once the schema is loaded into the registry, you are able to view the schema directly in the EventBridge console, and you should be able to download that as a text file and see it in VS Code too. That is entirely possible. Yeah.
No, that's great. So I've been hearing like both of these options have simple ways to do things, managed service ways, which I love to hear that too. I have some familiarity with EventBridge, which I think is amazing and a really great way to access different SaaS products. So which one is better? Maybe give us the pros and cons of both.
Right. That's a great question, right? So, unfortunately, with everything else in life, it depends. It really does. So, instead of actually going from the perspective of which one is better, it's always better to actually look at the requirements that one has on hand and then try to see which fits it better, right? So there is really no good answer for which one is better. But some of the pros and cons that we can discuss that can maybe help to identify which one actually fits the use case a little bit better, right? So let's say orchestration, for example. The pros, if you see, there is a central coordinator that actually coordinates all the communication, which means that it is easier to, in relation to choreography, it is easier to monitor and observe the whole system, right? Because all the logic is now confined to the coordinator, the business flow. And it also makes it easier to understand the high-level business flow, because once you see the coordinator, you will be able to understand at what flow the microservices are being called. So you should be able to figure out that flow of logic, right?
So going back to your choreography example, so if, for example, one of the dancers got out of line, it would be very obvious because things are supposed to be moving in the same direction. So if it got out of line, it would be really obvious, but also really easy to kind of change the choreography from one point. Is that right there?
Yeah, it is. So when you have like in the choreography pattern, when you have this distributed applications, distributed systems, when somebody goes out of the things, it is easier to observe, in the sense that from the dance group it is easier to observe. But since everything is kind of distributed, it is actually difficult to identify what is going on as a system as a whole. So um, that's why we have to come up with some kind of like a comprehensive logging mechanism, and then have like an intelligent system sitting on top of it to try and understand what's going on, right? So that is one of the cons of choreography. So monitoring and observability becomes tougher. The more we have the microservices grow, the more it becomes tougher there.
This sounds like a perfect segue into something on the other end, right? Where if you have this conductor and somebody were to get out of line, they have visibility to see who that person was and maybe have measures in place to correct it.
Correct, exactly. So since the coordinator controls all the microservices, and let's say for example you have like 5 steps that needs to happen, and since it's morely sequential fashion, it can communicate with step one, microservice one, and then microservice two, and then something happened to microservice three. Then we know that we have 4 microservices. Something has gone wrong with the third microservice. So the percentage track of completion of the process flow is easily identifiable, number one. And then you can also say that, hey, now that I have this particular microservice failing, so it is easier to restart from that particular microservice if you know which one is particularly failing, or which stage of the process we are in, right? So it is a little bit easier to handle the restartability factor, because we also have the distributed components, as well as we have like a flow. So it becomes easier to handle that point in failure, or restartability from the point of failure. Right?
Awesome. So I guess as a last question here, if I'm making that decision and per your words, we don't have a set choice of which one is better. Well, then what are some things that I have to keep in mind when deciding with these either of these services here?
Right. So as I said, both
Architectures.
has pluses and minuses. But we do have some design considerations that we can take into account when going between these two, right? There are also cases where architects and designers can actually create an amalgamation of both, maybe just get the best of both worlds and try to get a hybrid architecture in place. That is also possible. But some of the design considerations are like, the first one that's very important that comes to my mind is scope of the microservice. So let's say you're trying to split this monolithic application into smaller chunks, right? A microservice is something that does one job really, really well. So the scope of the microservice becomes very, very important. We don't want the microservice to like, hey, let's add like 3 or 4 features to this microservice, and suddenly it becomes like a small monolithic application by itself. So we don't want to go into that territory, right? So the scope with which you define what the microservice does and how well it does it is very, very important here. The second one is monitoring and observability, which we talked about just very briefly, right? When it comes to orchestration, you have the central coordinator, which makes it a little bit easier for monitoring the system as a whole. So it makes it easier to answer some of the questions like, what is the percentage of completion for a particular transactional flow? And who is responsible for a transaction to be fully successful? Things like that. And when you talk about choreography, on the other hand, the monitoring observability becomes a little bit of a challenge, because there is constant communication between these microservices by itself. And when the microservices grow into like huge numbers, so suddenly let's say you have like 50 other microservices for an application, and now it becomes more challenging factor. So you have to bake in, and you have to build that monitoring observability from scratch when you try to build these event driven applications, right? So this is the second one.
Got you. Yeah, so there's a couple of trade-offs and distinctions that we want to make there. Prashana, I really want to thank you for your time. We had a great learning session. I learned a lot. I know that much. But again, thank everybody for joining us over here at Reinforce. I hope you continue to enjoy the rest of your sessions. And until next time, see you then.
Bye.